So, we hear a lot about baby brain, right?
Oh,
That
absolutely.
that feeling of being a bit foggy, maybe more forgetful than usual, seems to really go hand in hand with pregnancy in those first months with a new baby.
It's such a common experience, yeah.
Yeah.
And, while it feels like this temporary fuzzy state,
Yeah.
that perception is actually hinting at something way more dramatic.
More fundamental.
Exactly. Something fundamental happening deep inside the brain. It's really just the tip of a very large, very dynamic iceberg.
And that iceberg, that's what we're diving into today.
Hmm.
This whole deep dive is about the astonishing structural changes happening in the human brain during that transition to motherhood.
Yeah, we're looking at pregnancy, the postpartum period,
Mm-hmm.
and maybe even getting hints about how these changes might echo, decades later.
We've pulled together insights from some really fascinating research for this.
We have. These are studies using like advanced imaging, MRI, and so on to track actual physical changes.
Real changes in the brain structure.
Yeah, things like shifts in gray matter volume or how thick the cortex gets in different spots. We've looked at sources exploring how hormones might play a role, how it connects to behavior, well-being.
And comparing mothers to be or new mothers with women who haven't been pregnant.
Right. That comparison is key.
Okay, so our goal here is to unpack all this for you.
Yeah.
We want to understand what's really going on in the maternal brain,
How it changes over time,
what might be driving it.
and crucially, what it actually means,
Hmm.
for how someone thinks, feels, interacts with their new baby.
Yeah, get ready for some potentially surprising stuff here.
Definitely. All right, let's get into it. So the research, it really challenges that common idea that baby brain is something that just pops up after the baby arrives.
Right.
These studies are showing significant structural changes are already well underway during pregnancy itself.
So it's not just dealing with a flood of hormones. The brain is physically remodeling before the birth. That kind of goes against what I would have assumed, that the changes happen because you're suddenly caring for this tiny human.
It feels that way, doesn't it? But one of the most consistent findings, especially from studies that track the same women before and after pregnancy, these longitudinal studies,
Okay.
is a widespread reduction. A reduction in both gray matter volume and cortical thickness.
Wait, reduction?
Yeah.
Like shrinking? Where?
It seems pretty broad, affecting quite a few different brain regions. Studies point to areas like the medial prefrontal cortex.
Involved in understanding others, right? Social stuff.
Exactly. And the cingulate cortex,
Yeah.
important for emotion regulation, decision-making.
Mm.
Parts is the lateral prefrontal cortex, key for executive functions. And the temporoparietal junction, also big in social processing.
Oh.
And these reductions, they're visible before the baby is born. It strongly suggests they're triggered by pregnancy itself, and they seem to kind of peak around delivery time.
So while someone might just feel foggy, their brain is actually undergoing this process that structurally looks like shrinking in some key areas.
Precisely. And it's not just gray matter either. There's this fascinating historical detail mentioned in the sources. Goes back to the 1930s, actually, but confirmed later with MRI.
What is it?
The pituitary gland gets significantly larger during pregnancy.
Ah, the hormone control center.
Exactly. It's pumping out crucial hormones like prolactin. And typically, it shrinks back down to normal size after breastfeeding ends.
Okay, so you could kind of think of pregnancy as this intense prep phase, this first wave of major structural remodeling.
That's a really good way to put it.
Right.
It's the brain's initial large-scale physical adjustment, getting ready for motherhood.
But the story definitely doesn't end there, right? At birth.
Not at all. The postpartum period, especially those first few months, it's a time of incredibly intense dynamic neuroplasticity.
And this is where some of the older studies got confusing, because they scanned at different times.
Exactly. Some earlier studies, maybe scanning weeks or months after birth, they sometimes found gray matter increases.
Which didn't quite line up with the pregnancy reductions.
Right. So the newer studies, scanning more often, longitudinally, they're really helping clarify this complex picture.
And the first 6 weeks after birth seem especially critical.
Very active, yes. Rapid restructuring going on. Some areas that reduce during pregnancy, like the amygdala.
Emotion center, fear, anxiety, but also positive stuff.
Yes, exactly. And the hippocampus, crucial for memory.
Mm-hmm.
Those areas actually start getting closer to the size seen in nulliparous women who have been pregnant by around 3 to 6 weeks postpartum.
So a rebound starts happening pretty quickly in some places.
Very quickly.
Yeah.
Yeah, one key study we looked at scanned women just like 1 or 2 days after they gave birth.
Oh, that's soon.
Yeah, and then scanned them again only 4 to 6 weeks later. And what they found in that really short time frame, A pronounced gray matter increase
Increase where?
across many cortical and subcortical regions. Places like the pre- and post-central gyrus motor and sensory processing,
Hmm.
the frontal and central operculum, inferior frontal gyrus, the precuneus, involved in self-reflection, memory, and subcortical structures too, like the thalamus and caudate, involved in relaying information and motor control. It just highlights the sheer speed and scale of adaptation right after delivery.
Okay, so reduction during pregnancy, then this rapid increase right after birth. Does it just snap back to exactly how it was before?
Well, it seems more complex than that, not necessarily a simple return to the starting point. The research suggests that even at 12 weeks postpartum, some areas, like parts of the dorsomedial prefrontal cortex
Mm.
and the thickness of the lateral prefrontal cortex, still show measurable differences compared to pre-pregnancy or compared to women who haven't had kids.
And it gets even more complex because your sources also mention that after those first rapid increases between maybe 6 and 12 weeks, some areas actually show a decrease again.
That's right. Specifically places like the cerebellum, the thalamus, and the dorsal striatum. They show this decrease, and it seems to kick in around week 3 postpartum.
Mm.
So it's not just recovery or returning to normal. It feels like a distinct phase of ongoing reorganization, different parts changing in different ways at different speeds.
It really sounds like sustained, intense brain sculpting. But
hmm
why? Why all this dramatic shrinking and growing and reshaping? What's the purpose?
Yeah, that's the million-dollar question, isn't it?
Yeah.
With the MRI tech we have now for humans, we can see these big macro-level shifts, volume, thickness.
But not the tiny details.
Right. We can't see precisely what's happening at the cellular level.
Yeah, we don't know exactly what's changing microscopically, like more neurons, fewer neurons.
Not definitively in living humans, no.
Yeah.
But based on a lot of research in non-human animals, these structural changes could involve things like changes in the density or size of neurons or glial cells,
Yeah.
the brain's support cells,
Okay.
or processes like synaptic pruning.
Like trimming back connections.
Exactly, like trimming a bush to make the remaining branches stronger, more efficient. Or myelination, building more insulation around nerve fibers so signals travel faster. It's probably a mix of these things.
And hormones. They must play a huge role, right? They're going haywire then.
Oh, definitely. Hormones like estradiol, progesterone, oxytocin, they're strongly suspected to be major drivers. We know from animal models they have a huge impact on brain plasticity.
But it's hard to pin down in humans.
It's been tricky, yeah. Finding really strong, consistent links between a specific hormone level at one point in time and these volume changes, it's been challenging. Although one study did note that higher progesterone levels at 12 weeks postpartum seemed linked to larger gray matter volume in some frontal areas.
So the hormonal link is likely there, just maybe complicated or unfolds over time.
Seems likely, yeah. It's
Yeah.
probably complex and time dependent.
Okay, so the how is still being worked out, but the why, the sort of evolutionary purpose, what's the main idea there?
The dominant theory is that this whole remodeling process is highly adaptive.
Hmm.
The brain is basically going through a biological transformation to get ready for and then meet the incredible demands of caring for a newborn.
It's specializing.
Exactly. Becoming specialized for motherhood.
Like tuning itself to be better at recognizing a baby's cry, responding to needs, bonding, all that.
Precisely. It's thought to be enhancing the neural networks involved in social cognition, emotion processing, reward processing,
Huh.
maybe even specific kinds of learning and memory that are super relevant to taking care of an infant.
It's literally building a more efficient caregiving brain.
That's the idea.
That makes a lot of sense.
Yeah.
But you also mentioned earlier this period of intense change, intense plasticity. It might also bring vulnerabilities.
It seems that way. I mean, it's amazing, but a brain that's rapidly rewiring might also be maybe temporarily more sensitive to stress or other things in the environment.
And how do these physical brain changes connect to the actual experience, like bonding or mental health?
Yeah, this is where the research gets really interesting. So studies haven't always found a strong link between, say, a mother's brain structure at one specific moment and her reported feelings of attachment.
Just a snapshot doesn't tell the whole story.
Kind of, but what they have found is that the dynamic change, how gray matter volume shifts over the postpartum period, that can actually predict future maternal behavior.
Ah, so it's the process of change that really matters.
That seems to be a crucial insight, yes.
Yeah.
Specifically, studies tracking women found that the amount of gray matter volume increase happening between about 9 and 12 weeks postpartum. that was predictive.
Predictive of what?
It predicted better overall maternal attachment scores later on. And significantly, it predicted less hostility towards the child.
Wow. So the brain changes happening in that slightly later window, like 2, 3 months postpartum, seem really important for the bond and positive interaction.
It really suggests that, yeah, the specific changes then seem vital for that developing relationship.
And which brain regions were involved in that prediction, the ones changing?
It was areas in the cerebellum, the amygdala, that emotion hub, again, the temporal pole, the anterior cingulate cortex,
Empathy, decision making.
right, the thalamus, and the dorsal striatum. These are all key parts of the brain's social, emotional, and reward networks.
Oh, okay.
So the fact that changes there predict positive maternal behavior,
Yeah.
it suggests these networks are maturing, specializing for that mother-infant interaction during this
Yeah.
time, and likely influenced by the interactions themselves.
So the brain is adapting as it learns to mother. The interaction is shaping the structure that supports it.
Beautifully put.
Yeah, it's really powerful. But on the flip side, you mentioned vulnerability. This period also coincides with increased risk for some pretty severe mental health conditions.
Unfortunately, yes. While it's rare, puerperal psychosis is a very severe condition that can emerge postpartum.
How does that present?
The sources describe it appearing suddenly, often just days after birth. Symptoms can include confusion, really strange behavior, rapid mood swings, and often terrifying hallucinations or delusions, which can sometimes involve the baby.
That sounds absolutely devastating and frightening.
It is, and tragically, it does carry a significantly increased risk of harm, both to the mother and the baby. The research really emphasizes how crucial it is to try and identify women who might be at risk during pregnancy, in the antenatal period.
To get support in place early.
Exactly. It offers an opportunity for intervention and support, just like managing any other health risk during pregnancy.
Okay, so looking a bit further out now, beyond those intense early months, does this maternal brain transformation leave lasting effects? Maybe influence brain health later in life?
Well, there's some intriguing research suggesting it might. One finding from our sources points to the actual way someone gives birth, potentially influencing the trajectory of those very early postpartum brain changes.
Really? How so? The type of birth matters.
It seems it might.
Yeah.
Yeah, one study compared mothers and found that those who had a scheduled C-section, meaning they didn't experience labor, they showed larger increases in cortical volume and thickness from late pregnancy to early postpartum compared to women who did experience labor, whether it ended in a vaginal birth or an emergency C-section.
Huh. So the intense physical experience of labor itself might affect the rate or the pattern of how the brain remodels right after birth. That's unexpected.
It is, isn't it? And it raises fascinating questions about how those different early trajectories might relate to outcomes down the line.
And what about even further out? Decades later.
Yeah, this is really interesting. Studies comparing elderly women have found an association. Having had more children seems linked with signs of less apparent brain aging later in life.
Less brain aging. So motherhood could potentially be protective for the brain long term.
That's what the association points towards.
Yeah.
Women who'd had more children showed measures suggesting better brain maintenance in old age. Things like better white matter integrity, differences in cortical and subcortical regions, overall larger gray matter volume and thickness compared to women with fewer or no children.
Why would that be?
Well, the direct biological effects of pregnancy and lactation might play a part, but researchers also suggest that the lifestyle associated with parenting over many years.
The constant demands.
Yeah, the cognitive demands, the multitasking, the problem solving, the social engagement, that could be a huge factor in building that long-term brain resilience.
So the challenges of parenting might actually be like a long-term workout for the brain, potentially paying off decades later.
It's a really compelling idea. It highlights how profound this transition is, impacting not just the next generation, but the parent herself, potentially across her whole lifespan.
Of course, this is still an evolving field.
Absolutely. Researchers are calling for bigger studies, more diverse groups of participants, scanning women at many more time points over longer durations, and using even more advanced imaging techniques to really nail down those cellular and molecular changes driving this incredible transformation.
Okay, so bringing this deep dive toward a close, what's the core message, the essential takeaway from all this research?
I think what we've learned is that becoming a mother involves this truly dramatic, really dynamic transformation of the brain's physical structure.
It's not just baby brain fog.
Not at all. It starts profoundly during pregnancy with those widespread reductions, and then continues intensely postpartum with this complex dance of increases and decreases in different areas at different times.
Mm.
It's just a period of remarkable neuroplasticity.
And crucially, these changes aren't random.
No, not at all. They appear deeply adaptive. It's like the brain is being sculpted to support the incredibly demanding, but also rewarding task of caring for a new life.
Yeah.
And these changes keep maturing over time, and they seem intricately linked to how that crucial mother-infant bond develops.
And while there are vulnerabilities.
Yes, while there are vulnerabilities, like that rare but serious risk of puerperal psychosis, the overall picture seems to be one of profound biological adaptation and specialization.
It's just incredible to think the adult brain is capable of this scale of transformation.
It really is. It's one of the most striking examples of adult brain plasticity we know of.
So here's a final thought maybe for you to chew on. Becoming a parent isn't just about your external world-changing routines, responsibilities. It is quite literally a physical restructuring of your internal world, your brain, happening on a scale that's arguably unique in adult human experience. And the effects of this profound biological shift, they might echo not only in that immediate bond you form with your child, but potentially contribute to your own brain's health and resilience decades down the line. What does this revelation about the maternal brain tell us about our human capacity for adaptation, for connection, and maybe the long-term power of nurturing itself?